In today's lesson on sequences and series, we are going to have a look at applications in real life. Example 1. Max trains to run the Comrades Marathon. He runs 3 kilometers in the first week and increases his distance by 2 kilometers each week after that. First question, what distance did he run during the 11th week? Now, we need to start off by getting a sequence from the information that was given. So he started running 3 kilometers and then he increased it by 2 every time. So the next week was 5 and then 7. And from this, we now know that A, our first term, is 3, and we have a constant difference of adding 2. They ask us in A, his distance that he ran in the 11th week. So that is the specific term value for term 11. So we're going to use the TN formula. In this formula, we want the term 11. So A is 3. It will be 11 minus 1 multiplied by 2. And that means that in the 11th week, he ran 23 kilometers. B. What is the total distance he ran in the first 15 weeks? So this time, they're not speaking about the specific 15th week, but about all the weeks up to the 15th one put together. So that means we are going to calculate the sum. And we want the sum of the first 15 weeks. So N is 15. A is still 3. And D 2. And this means that he ran 255 kilometers in total in the first 15 weeks. C. It is said that an athlete should run at least 600 kilometers in preparation for the Comrades Marathon. How many weeks should Max train before he will meet this goal? Now, we already know that A is 3 and D is 2. Max needs to run a total of at least 600 kilometers. So that means that Sn, the total sum, is 600. So now we're going to substitute into our S formula. The sum is 600 and we do not know the N value. Now we can simplify and then take everything to one side equal to 0. Next, we can use the quadratic formula to solve N. N will be 23,52 or minus 25,52. And of course, the minus 25,52 is not valid because we cannot have a negative number of terms. And now the 23,52 means that after 23 weeks, Max is still a bit short of a total of 600. That means that after 24 weeks, he will have at least 600 kilometers. Example 2. A tree with an initial height of 1,5 meters is planted. In the first year, it grows 1 meter. In the second year, it grows 0,5 meters. And in the third year, it grows 0,25 meters, and so forth. Each year, the tree grows 50% of the previous year's growth. What is the maximum height that the tree can reach? Now, we need to start off by forming a sequence. In this case, the 1,5 meter height is not part of the sequence. It doesn't form a pattern. But how the tree grows forms a pattern. So we start off with 1 meter growth in the first year, then 0,5, then 0,25. So in this case, it's clear that A, the first term, is 1, and R, our constant ratio, is a half because we multiply by a half every time. They ask us for the maximum height that the tree can reach. That means that if the tree continues to grow every single year, and that is sum to infinity. So we need to calculate the total growth of this tree up to infinity. Now we can go and substitute our information. So A is 1 and R is a half. And then you will see that this tree will never grow more than a total of 2 meters. The question, however, was the maximum height of the tree. So to get the maximum height of the tree, we're going to start off with the original height of the tree and add the total that it can grow, and that will give us a maximum height of 3.5 meters.